All right, guys, hopefully this one's just a little bit easier. We will continue with this when I get back next week, but this should be a pretty decent little mini lesson after our implicit differentiation last time on Tuesday. So what we're doing right now is we're working with what is called differentials. All right, we took the derivative last time. Our derivative was compiled of y and x variables. So we needed to know our x and y point to be able to find the slope. Here with differentials, that dy dx, we actually can treat as two separate variables. dy is our change in y, and our dx is a change in x. We might know the change in x. Typically, our dx could be rewritten as dt, time, change in time. So if we know how much an object is changing over time, so if I'm checking it every second, every minute, that's my change in time, we can look at the dy and be like, all right, my height is changing this much when my time is changing this much. Depends on what we're looking at. So that dy dx we can actually separate so we can solve for different pieces. So for example, I have on the board, we have our function y equals x to the fifth plus 37x. I know my x value, and I know my change in x. So this could be my change in time. This could be a tenth of a second, okay, a hundredth of a second, whatever. And then find my dy. I want to know what my change in y is when my change in x is 0.01. Now my y and my x have different rates, okay? The y goes up when the x goes up, or however it's changing. So the way that this looks, we can take the derivative of y equals x to the fifth plus 37x. This becomes dy dx equals 5x to the fourth plus 37. Typical derivative. Derivative of y with respect to x. But now my goal is to find my dy. So what I'm going to do is I'm actually going to isolate my dy by multiplying both sides by dx. So my dy equals 5x to the fourth plus 37 dx. Well, I know what x equals 1. So dy equals 5 times 1 to the fourth plus 37. And I know what my dx equals, it's 0.01. So 1 to the fourth is 1 times 5 plus 37 is 42. So my dy equals 42 times 0.01, which ends up giving me, do you guys know the math real quick? Because I don't, but now I do. It's good. This ends up giving me 0.42. Ta-da! Differentials. I can isolate that dy dx. I knew my change in x, and I used that to find my change in y. How is the y changing? Okay, let's look at another example. Okay, let's do, we have x plus y equals x times y, x equals 2, and dx equals 0.05. All right. So, using that implicit differentiation, which we learned last time, we're going to take the derivative. So I'm going to get the derivative of x, which is 1. Derivative of y is 1 dy dx. X times y, I've got a left d right plus right d left. Left d right plus right d left. I'm going to group my dy's together. So I'm going to subtract this one over, and then I'm going to subtract the 1 over. So I'm going to end up with dy dx minus x dy dx equals y minus 1. We have the two dy dx's, so I'm going to factor that out. 1 minus x equals y minus 1. I'm going to divide the 1 minus x over. And I'm looking at my dy dx equals y minus 1 over 1 minus x. Our goal is to solve for the dy. So again, I'm going to multiply both sides by dx. So y minus 1 over 1 minus x dx. We know our x value and we know our dx value, but we don't know y. So we're going to come back to our original and we're going to plug x in and solve for y. Okay? If they don't give us the y, we have the original equation, which we should be able to solve for our y variable. So I'm going to plug in my 2, x is 2, plus y equals 2y. So I'm going to subtract my y over. Y also equals 2. So to solve for my dy, I'm going to plug in that 2 for y and the 2 for x, and I'm going to times by the 0.05. So we get 1 over negative 1 times the 0.05. So the answer is negative 0.05. Okay? Differentials. Not too terrible. The only thing here is that we know our dy dx, the change in y and the change in x, we can separate those and use them as individual pieces. Okay, short and sweet, get to work. You got a lot of time to practice. This assignment is out of the book. It's short. Try a few problems, see how you're feeling, and we'll pick up from here when I get back next week. Okay, see you guys.